I'd like to thank our guests for joining us on this edition of Insulation Systems. It's a power panel, and these are power people. So Javi McGuiggan from Cargill Bioindustrials. I got that right, didn't I? Thank you for joining us. Thomas Norrby from Nynas and Claude Beauchemin from TJH2B. Thank you all for being part of this. Before we get started, if you would just kind of briefly tell us a little bit about yourself, a little bit about your background, and then we're going to get right into the discussion. That's me. I'm the moderator, and now we're going to talk about Professor Thomas Norrby.
Okay, so thank you. I'm happy to start up and open up this session here. I am an organic chemist by training, and I worked in the lubricants and oil industry for about a quarter century. And now I'm working in Nynas with two business areas. One of them is the dielectric fluids for the insulating for the electrical industry. Sorry. So I'm active in the IEC and cigarette type environments, and we work closely with our key customers in the transformer OEM industries and also with the utilities. So it's very nice to be here today and to share a few of our thoughts and experience from the field. Yeah.
Thank you, Thomas. Oh, there's his company information. He just said that. And Javi, if you'll go next.
Awesome. Thank you, Ellen. Thank you for inviting me for sure. My name is Javi McGuiggan. I am the Global Business Director and Assistant Vice President of Cargill Bioindustrial, as Alan said. I have been leading the power systems business with dielectric and cooling fluids within Cargill for over 5 years now. I originally am a hydraulic engineer that ended up going all the way through her career in very technical but still business related jobs. So I'm the commercial leader and I also have the technical team under me. But we have the beautiful mission of turning some of our derived nature chemistries from renewable resources into industrial applications. And of course, FR3 is one of the star products of Cargill. And that's why I'm here and happy to join and share everything else that we're going to talk about today.
I love that you've got the FR3 logo behind you. You say it's one of the star products there, but you can help FR3 on the map. So that is an appropriate logo to have behind you. And Claude, you and I met a long time ago. You are with TJH2B and one of my go-to people on lab testing for transformers.
Thank you, Alan. Good day, everyone. I'm Claude Beauchemin from TGH2B Analytical Services. I'm also a chemist by training, but I have been in contact with the electrical engineer all my life, so I'm kind of in between two worlds. I've been 45 years in the field of industry and more specifically transformer and transformer insulation material. First part of my career was with online monitoring. I was part of a company that introduced the online monitoring and transformer. And I moved to TJH2B for 14, 15 years ago now, which was kind of back to my roots. I did start the lab to support monitoring business, and now I am on the other side of the barrier, doing full-time in laboratory interpretation and testing. The bulk of my job is more on the interpretation side, the specification side, that on the analytical side proper. We also have a conference at TechCons every year where we gather a leader of the industry for 2 days, more than 2 days, not 3 days, reunion, meeting of the mind, meeting of the technique. So with this, Alan, back to you.
Thank you. By the way, I think TechCon is one of the best technical conferences I attend every year. Because it's very utility focused. It's a great conference. So a little promotion for TechCon. And I think it's in my hometown of Atlanta, Georgia this year, correct?
Correct, in March next year. Coming up fast.
I'll see you there for sure. So the first thing we want to do before we talk about oils and fluids, even though that's our topic, because all of you I know are not just focused on that one thing. One of the things that you bring to the market, one of the things I value the most about you is you have a very perspective of the business. As you said, Javi, you've kind of focused from your original. You're the only hydraulic engineer I know, by the way, but you focus on hydraulic engineering, and you've learned the power industry, and you've definitely learned the transformer market. So let's talk a little bit about transformers. We're at a unique time in the transformer market, where we've been and where we are. Your perspective of where we are in the transformer market, Europe, UK, and North America.
So definitely, as you said, unique time, incredible accelerated growth pace and demand for an industry that you would think was super established and very traditional. And then the growth rate that we've all seen, no one's surprised by it by now. We've been living through that since COVID. I think what we're all working on now, and us very close to our strategic accounts and our OEM partners, is really understanding the market dynamics and how long even this is going to last. The accelerated growth in the industry of transformers, we just heard a study from a bank, I won't name the bank, but they did a study where they think they are projecting being out of the industry a 5x growth in the next 5 years. And that is like absurd level of numbers that we're all, you have to get multiple sources and balance. But overall, our partners and customers just say, we knew the wave was going to happen. We just didn't know everything would happen at the same time. Meaning, aging grids in, let's say, Europe and developed countries, aging grids, changing the source of the energy. That requires all new units. If you're moving to renewables, that means all new units, and that's a whole investment. Expansion of grids where you have newer population or growing or more developing countries, the electrification of everything from water heaters in California to, of course, cars and vehicles and all the other things. So now we need more energy. And then the sustainability push in our case is been a key driver for trying to look for different options and very aligned with the renewable energy industry. So we've seen a lot of shifts from supply and demand being so unbalanced of more developing regions, like you say, India, China, Korea, moving into higher levels of penetration in markets like Europe and North America because they found themselves out of capacity. But now, very smartly, also now those regions are investing and expanding capacity and expanding plants. So I hope it won't be soon because, building a whole plant of transformers and like we are also expanding our plants, it's not something that happens one day to the next, but hopefully getting to a better, healthy level of demand and supply, for sure.
A healthier level of demand. I don't think there is such a thing when you say 5x, but
balance, just the balance. It's going to be hard to catch up.
Thomas, comments on that? Your thoughts?
Of course, we share much of the same opinions. It's interesting to see mature industries suddenly being yanked from 2 to 5% yearly growth to multiples of that, or even 5x, which is a sort of, I don't know, fintech or IT type numbers. And of course, when you have to build hardware and actually have physical products, that's not going to happen because it's impossible. So what we've seen, I mean, the European OEMs have invested wisely in production capacity in China and in Vietnam and in South Korea and in India. And all of these units are coming back to Europe and even more so to North America, of course. We see also the big local South Korean super brands like Hyundai and so on. So from our perspective, we see a lot more interaction with many, many more OEMs and also huge orders driven by the things that Javi just mentioned, of course. But I mean, I really want to underline the huge impact of renewable energy in large offshore wind installations such as we have around the North Sea. These are absolutely massive, Apollo type projects. It's like putting a man on the moon. They're completely rewriting the story about energy around the North Sea. It's no more coal. It's it's an oil is phasing out, and it's absolute massive, and it will be sustained. That part will be sustained because it will take such a long time. So yes, I believe there's been like an inflection point, and I think that we will go as fast as we can for a long period of time, because I don't see any reversal of the electrification. I mean, we will sort of it will be snapped up as quickly as it can be produced. So I think it's really a permanent shift of tempo, and we need to find good, stable, standardized way to work, including the use of all the products and fluids and support software, whatever. So it's a really exam time for the industry, right? Can we deliver?
It's a nice, yeah. Yes, yeah, we deliver. And now utilities are buying slots, which has never happened before, at price prevailing. And, when you think as a manufacturer, I know some of the big boys are, I know they have a $30 trillion backlog, $30 billion backlog at Hitachi Energy and GE Vernova and Siemens Energy. So when you have that kind of backlog for transformers and other equipment, then you can invest in building plants, because until you have that kind of an order entry, you're not going to spend the kind of money it takes. But everybody is building either additions to plants or new plants. Claude, you see it from a different perspective. You see it from the standpoint of the existing infrastructure, but now this new infrastructure. What are your thoughts about the transformer market?
Well, it sure is an interesting time. No question asked. Of course, my perspective is more on the material going in a transformer than in their number. But even the increase in the number will challenge the laboratory in the roles. We will have to add equipment and people. Equipment is easy. People sometimes is another story. So we will also have to live with that. I have to say that since I got in that industry 45 years ago, I've seen a lot of change. It was effectively initially very traditionalist industry. Okay, nothing was moving. Everything was taking forever. I mean, it was the same, is the same, is the same. And at some point in time, we start to see some pickup in the pace of evolution and development. And today, it's really active. We're talking about liquids today. It's the same thing on the solid material. It's the same thing in everything. One of the challenge that the analytical side have to address is the evolution of interpretation. We used to see things and they were meaning something, good or bad. And now the interpretation evolve as the material evolve. So, for example, gas and oil. Traditionally, it was okay, you have hydrogen acetylene. Well, it's arcing, and that's the end of the story. Now we have new liquids, and the interpretation is a bit different. And we have to be careful. What a level used to be a panic, so now will be normal with another liquids, and the reverse is true as well. So there's an evolution, no question asked. The push for vegetable oil, renewable, and long-term supply is there. The amount of demands is tremendous. Will it be satisfied? Remain to be seen. And we may see if we could not supply the power at the entry of the industry, some restriction in the future, which we try to avoid, of course. One thing is sure is the demand on the equipment is increasing. Because the demand increase, the supply is restricted. It's implied that whichever you have in hands today, you need to keep it going for maybe longer than expected. And I always use that anecdote when I was new in the field, and I was talking about mineral oil because it was the only thing in town at the time. When the mineral oil was degraded enough, the situation in those years was replace it. Send the oil to the boiler rooms, burn it, and just put new one in the sun.
So simple.
Yeah, and it was acceptable because it was inexpensive. No longer today. We have to be more careful than that.
I love, if you allow me, Alan, I loved his comment about, because he's such an expert in the analysis. His comment of learning of new things. We, with natural ester, still being the new kid on the block, almost
Right.
30 years in the market, but it's still the new kid on the block for this industry. We always use that quote from Einstein of, if you judge a fish by its capacity to climb a tree, it's a pretty bad animal. And that's what we need to get over in this.
Einstein said that. Did he really say that?
He said he literally said everyone is a genius, but if you judge a fish by its capacity to climb a tree, it will live its entire life thinking it's a stupid animal.
That's fun. I know that we're going to talk a little bit about this, but I know there's some learning that the whole industry is going through as it relates to some of the mineral oils, or excuse me, esters out there. And that's something we're going to talk about if we have the time. I want to bring that back to you, Javi. Let me move to something else, right? So you've got all of this new capacity coming online, great growth. Right now, if you were thinking about what transformer owners, current owners, operators, what are some of the biggest things that they're facing as it relates to unplanned outages? I mean, just speak in general about the transformer, not necessarily about the fluid. But Thomas, let's start with you. Protect me. I'm a transformer owner, and I can't buy them fast enough to replace the old ones. How do I avoid an unplanned outage, and what should I be aware of?
Of course, the noble art of asset management then is becoming even more important. So I think if I were responsible for asset management, I would make sure that I train and retain my key staff, so that I have people out there that know what they're doing. Taking care of the equipment, thinking about how to, it's everything from, as Claude said, interpreting the analytical data correctly, to, let's say, turning every stone and realizing that the value of the systems which are up and running is actually probably greater than you think. There was also some interesting news at the Paris session of the SIGRE this summer. In one of the keynotes was from Professor Werle from Sharing Institute about some recent findings on how these renewable energy wind farms and turbine collections are doing, what's happening with the step-up generators. So it's now so big, massive, like 1 million new transformers in the field. So the problems are starting to show up in the statistics, and there are differences which are not so subtle when you have lots of harmonics and so on. This is known from before, but now we're starting to see how it plays out in the field. So of course, many people get involved in the renewable energy field, and make sure that you stock up on sufficiently know what's going on and follow the science, the development of the science, because otherwise I think you would get into more problems with the equipment and so on than necessary. So in general, try to increase the quality of the work that you do. It's because many things are more critical than maybe what you thought before. Like
Claude, you're next. Talk about this same thing. How do you help utility managers avoid unplanned outages?
Well, first of all, the use of unplanned outages is a new thing. In the past, you have an outage or you didn't. The idea here is to try to detect early warning sign that maybe something is blowing up, and to plan on outage to investigate, as opposed to wait that, well, transformer failed, now we turn around and replace it. The main problem, of course, is the transformer sitting on the pad that used to be there is no longer there because we have that pressure on the supply. So the way to help is the same as in the past, but maybe we speak a little bit louder now, is to interpret the sign, try to see if you could extract from those signs given by analytical technique or online monitoring of possible impeding issue. Try to have an idea if this is coming up fast or slow, which is not obvious to say by any stretch of the mind, and educate. tell the end user, okay, this symptom in the oil, this level of moisture is not necessarily the oil, it's maybe the paper you should look at. We have new tracer of aging. We have methanol now. We used to have only furan. Well, if that starts increasing that speed, probably you should look at it, and so on and so forth. So it's a question of education. We have to be in the loops. We do learn every day. We don't know everything by any stretch of the mind, but it's to be in the loop and try to educate and give tool to the operator to interpret what we see. And it's a two-way. I mean, the lab could do so much, the operator have to do as well.
Javi, same question.
So all I'm going to say pertains to natural esters, of course. That's my knowledge. And you have to help me in my campaign that esters, as the name, synthetics and naturals are very different animals themselves. So naturals is what I'm going to talk about. So thankfully, and this one of the reasons why naturals have grown so accelerated lately is that we almost provide a couple of technical reasons why you get a little like almost insurance to prevent this from happening. So the first thing is just with units that you think maybe are aging and they would need to be changed, or normally in your normal schedule before, if you had availability of transformer, you would have just renewed them. The oil change to FR3, the molecule of vegetable oil, in particular soy, is very long, and it engages part of molecules that could be in the transformer from moisture or free water, that for some reason changes in temperature, whatever enters. So by kind of trapping part of the water molecule, it just keeps it away from the solid insulation. And with solid insulation staying drier, you effectively can prolong the life of a unit. So that's part of one of the insurance. The other one, and some utilities are using this concept, even though the standards are still, going to take a while to catch on for the concept of dual rating in transformers. But some, more innovative people in the industry, and we already have some utilities in the US utilizing the concept of having the same size of a nameplate unit, but knowing that because of the more than double flash or fire point in natural esters, you have this kind of built-in risk that if you have a low load that's higher than what you had planned for, you have plenty of capacity with that same unit. That's like, again, like a safety insurance thing. Or in the case of harder availability, you can buy one size of transformer that now can work for more than one function. So where you used to need a 150 and a 200 volt, whatever your unit is, now you could use the same unit for both purposes until you can get more. So that dual use, because of again, it's a concept that's still traveling the roads through IEEE of dual rating nameplate to give you this access to a heavy load or unplanned peaks, is some of the things that we offer that people are taking advantage of. In Europe, it has a different name. The concept of using that higher temperature rise capacity goes more under something called SPL, or sustainable peak load, instead of dual nameplate rate. That's kind of the jargon in Europe was sustainable peak load. And it more refers to building a efficient, smaller, more compact unit. So then you get the advantage of using less of the other more expensive ingredients, components of a transformer, and making a smaller unit to get the same amount of power. So those are some of the things that you can achieve with esters that help in this crisis of supply and demand.
Just remind me, I'm going to ask you about retrofilling because we do have a question, and I'll get to it. But Thomas, what you just heard about the SPL and talk a little bit about that from your perspective.
Yeah, I mean the ability to understand, withstand overload, of course, is perhaps even more critical with renewable energy. If you have a gust of wind, or the clouds move back and forth, the sun and the solar panel. So fluids with high capacity fluids that give very good cooling, lower operational temperatures, of course, increase the withstand of overload. So that's something that we look very carefully at, and we have range of products with different performance grades. So an upside from a fluid maker's perspective would be that the increasing demand for high performance products, which generally is interesting for us as manufacturers, and it can help solve problems and dampen out these things. So it's a sign of the times that it's going on in both under the IEEE and the IEC world, yeah, for sure. So a bit more using the liquid quality and let's say ability as an integrated part of the toolbox, rather than just thinking that it's just a set performance and you can't do anything about it, because there are different ways to skin that cat these days, right? I mean, if you look at the global market, it's still 80% Naphthenics and mostly in some group one, but the other emerging fluids are most certainly non-zero, which was not the case 50 years ago or 30 years ago. So learning to live with that and learning to utilize them for the best application is key, I think, yeah.
So we know this is twofold. Number one, utilities have always, that's why you can run something higher than rating, right? So you can overload a transformer. That's expected because of climate issues, because of lack of supply. Utilities are running their transformers, and you just said in the renewables market, it happens quite naturally from wind blowing or the sun shining or not. But pretty much all utilities tend to be running their transformers at certain times for longer and higher at peak loads. Talk a little bit about, if you will, the impact on the fluids when that happens, and why, or I don't want to say which fluid would handle that better, but why it is important to know the parameters of the fluids you're using. I'm going to start with you on that, Claude, because you got to see a lot of the repercussions of overheating transformers in oil testing, right?
Well, the overloading or high temperature operation, if you wish, will affect liquids, will affect paper. So the thing to check, I think the main change I've seen is the awareness of the question of the moisture moving in and out of the paper. In the past, this was okay. We're taking the amount of moisture in the oil as, a fixed value, which is not by any stretch of the mind. And often this could cause some issue. For example, if you overload your transformer and your paper is wet, then you will push a lot more water in that oil. That's what is good for the oil popper. It will affect the oil, but it will also affect the operation of the transformer. And one of the parameters that could be affected is the dielectric breakdown. And this could cause issue not so much during the time you operate, but when you shut down and everything starts to cool down rapidly. And if you want to restart, too rapidly, you may end up in a situation where you got enough moisture in that oil to lower the breakdowns to a dangerous level. That's one example. Aging of the paper, of course, is another one, is a classic one. But on the side of aging of paper, things have evolved. We have now 2 markers for the aging as opposed to 1. I mentioned methanol, ethanol, as opposed to furan. In fact, the 2 make a pair that help us understand what's going on. The other is the evolution of what is the end of life of that paper and what are the initial conditions on that paper. So there are a fair amount of work ongoing there to try to evaluate. In fact, Sigrid just about to start working groups on what is the magic number in terms of DP for paper. So all those evolve. The oil popper, of course, the warmer it is, the more it will degrade. The oxygen has an effect là-dessus, moisture have an effect on it. Compatibility of material also will be an issue as you increase temperature. What could be compatible at low temperature because the interaction is so slow may start to be annoying at higher temperature. So there are a bunch of challenges that we will have to look at and address. So my life will still be interesting in the future.
For sure.
We all have career, what is that? We all have good security in our careers. We're all correct.
Good industry to be in, for sure.
want to switch gears a little bit. I know that something that I read just recently, typically you run, if you have an ester, a natural ester, I don't know if this is true of synthetics, you can run the natural ester transformer higher, is hotter. But then there's some work being done that's more proprietary than it is a standard across the industry. It's kind of one paper company saying, no, if you use our high grade, high temp paper, you will be able to, you're going to get this result. It's kind of a switch to be able to do a proprietary change, by saying, and we all know who the giant paper provider is for the industry, but does that really matter if you're using a high grade paper? Does it change the amount you can overload a transformer? Talk a little bit about that.
Sure. So first of all, I no one is meaning to attack anyone, because at the end of the day, we're all working for our companies and representing their best interests, right? So it's just a matter of balancing the true good properties that your product can bring to the industry with just true facts that let the whole industry move forward. So that balance is something that I'm just a big advocate of. That let's not throw anyone down to throw someone else up, when all solutions, because of this world we're living in where we just need more energy and need more transformers, there's room for growth for everybody. But the theme you're talking about here is, does it change the temperature rise capacity that you can achieve when you have one paper versus another? It does, and it can, but there are already temperature rise benefits that you can get out of your unit without using the super expensive, highest top quality paper, right? I'm sure if I worked at that company, I would have the best reasons to recommend why and when that extreme of need of application is necessary, and the whole combination in the transformer also has to match, right? You need other pieces to be high heat compatible. And we were even in conversation of, because I think it's important for us as a united front to say, in transformers, high heat, well managed, a good temperature can be a good thing. So first of all, let's not be scared of the concept of letting the temperature rise or operating transformers at a bit of a higher temperature in times and situations when it's needed. If managed correctly, it's an advantage for the system. So first of all, we were united in the front of high heat is not necessarily bad. But then how you effectively get there, I feel the truth is that they are different. You don't absolutely need one without the other. Both complementing you gets you to a much higher level that not everyone will need. And it does make a unit more expensive in a time where maybe that's not what a company can do. So I would say definitely it's application by application, point by point. You might not need all your transformers in your network to have that capacity. You might know of hot areas or more populated areas that have ups and downs where you'd want to have that safety. But for other cases, it's not necessary for a paper and a high temperature fluid to go together to achieve some of those benefits.
Thomas, do you agree? Thoughts on that?
Yeah, of course. And you have to remember that every temperature above ambient is caused by power losses in the transformer, right? So you necessarily want these to be as low as possible, because you're wasting energy that you could have sold otherwise. So the main goal of the transformer fluid is to make sure that the transformer run as cool as possible, not wasting any energy. It also reduces oxidation and hydrolysis. And as you know from the Arrhenius rate law, with the doubling of with the 6-degree higher running temperature, the paper aging is roughly twice as fast. So it's very integral for the long and healthy life of the transformer to keep running very cool. We have lots of clients in the Middle East and Africa with very hot ambient temperatures, 50, 55 in the summer in Abu Dhabi and Kuwait and so on. And they're very keen on having fluids that make the transformers run cool and last long. I think also for distribution transformers, at least in Europe, my impression is that maybe half of them are fairly lightly loaded. they are positioned in the grid in such places as they will get maybe 50% traffic. It's also very common to have one unit in backup. I was recently in Romania at the power station, and then they had an old transformer they were running, and then they had a brand new one, which were sort of just sitting there humming along, waiting for the old one perhaps to die or something. So there's a lot of capacity that's sitting ready to roll. And then, of course, in very dense grids like Netherlands and so on, where you have a lot of power takeoff and also a lot of input from renewables, then you have some nodes which are desperately overstretched, really. So one of the things that we're interested in is looking at operating by modifying existing equipment instead of waiting for 5 years for a new transformer. You have an ONAF and you put on some fans, an ONAN, and you turn it into an ONAF, and you change to a lower viscosity fluid with improved cooling properties and operate the unit. So I think that this kind of MacGyvering can decongest crucial points in the grid, and we have some projects that are starting up around that theme. So that's making more out of what you already had, as you pointed out earlier, right? So stretch and bend and follow, and try to put in the extra support where it's needed in the grid. Yeah.
Okay. Claude, you see, I want to go back to the paper, the impact of overheating the impact of anything on the paper, because the life of the transformer is the life of the paper. The oil protects the paper, but the life of the transformer is the life of the paper. Talk a little bit about what you're seeing and the growth of the esters, natural and synthetic esters. It's got to have been something you've watched every year. I'm familiar with a lab that had a 1% annual growth until it had a 1.5% annual growth until it had a 2% just in the testing that they were doing. So that indicated, the number of new ester-filled transformers in the market from all walks. Talk a little bit about what you're seeing as it relates to the oil, the fluids, and the paper.
Well, we're saying the same thing as what have been discussed here. They are increased there, no question. Honestly, I will be hard pressed to give you a number rather than another, but we do definitively see an increase in the use of natural ester, no question asked. What we start to see, not so much in the lab, but in the industry, is the apparition of a few other materials, a few other liquids. Gas to liquid, for example, synthetic, some other synthetic liquids. And this is a continuation of what we have seen in the past. Nobody remember, but we used to have PCB, pure PCB, as an insulating liquids. We used to have silicone fluid at some point.
Silicone. I was going to say silicone.
Okay, so it's not new. And by the way, you were complaining that 30-year and you still look as new. Well, first the mineral oil insulating transformer was 1890. So yeah, 30-year in that perspective is still reasonably recent. But you should be proud of the growth that you get in those 30 years. As far as paper is concerned, I'm more saying evolution on the investigation of paper. We pay a lot more attention to how paper behave. I just complete work with another SIGRE working group on the dry up process in the manufacturing. Okay, how much drying up is too much? How much it's held? What are the conditions that should be stated to guarantee the performance of the duration of the transformer? We used to say, and you still see that in the standard, a well-dried transformer should be 20 years, 17.5-year life at nominal loads. How true that was, or how true that is. So we are saying study there and push there and an evolution. And I think that one of the things we will see in the future is more testing on the paper up front to establish a kind of a baseline for each transformer to say, okay, if we do test 10 years from now, well, at the beginning, we know it was that. Today, if we do the test 15 years after the fact, we assume the beginning was that much because nobody was testing the DP of paper in manufacturing. So this thing does evolve because we have been doing testing on the oil, on the transformer. We got result. We interpreted the best way we could, but we have to make assumption. And now we realize that maybe it's a good idea to test that transformer as it leaves the plants for some baseline reading on various domains, not just the chemistry, also the electrical side, that in 10, 15, 20 years from now, when we will evaluate the remaining life of that unit, we will know, okay, from those 20 years, start from here to there. As opposed to say we are there and we assume it started from there. So that's another evolution we're seeing.
As you know, Alan, we always talk about how conservative this industry is. And I feel this topic of working with high temperature and high heat, either the dual nameplate or the sustainable peak load concepts, they're new. They're innovations in this world that have been a little more pushed and accelerated because of the super unbalanced demand and supply that we have. So I think we will learn more and more and get maybe more comfortable as we learn more about these concepts, but they are newer. And there's a great study that our friend, I think you froze, Alan, our friend Fernando from the Copper Association, he always shares the analysis of the losses, right? The load losses, high load, low load, and no load losses. He has a whole paper and analysis that he presents at every country that I'm at, conference that I'm at, to kind of balance at the end of the day, we hopefully need to start looking at the overall benefits and limitations together, not just the limitations, because it's an innovation. It's a push for change, but we'll learn more.
And here's the good thing. We have more questions than we will have time to answer them. So I'm with pressure right now. And I said, we're not going to get through all these questions because number one, you all know what you're talking about. And number two, we'll get a lot of good questions. First question, Thomas, it's really for you and for you, Javi. And it might be a yes or no. And if it's a yes or no, let's do it. Most retrofilling cases are required to be done on site. Retrofilling, that kind of says you're going to do it on site. What are the key parameters need to be checked to ensure that retrofilling on site would not be a risk for continuous operation, aka would not be a risk for unplanned outage?
Yeah, I could start there. I mean, retrofilling, if you're not talking about top-up, you're talking about a complete change-up.
And not top-offs.
Oh, so obviously it's the same for any industrial lubricant system. You will take, ideally you will have the time and opportunity to take a sample of the oil which is actually in the unit. You can test it according to 60422 and make sure you understand what condition it is. And then miscibility study, this is whatever you're wanting to put into the oil. Ideally, you get most of it out. Maybe 95% can get out, but the nasty bits will be down there. The sludge will be impossible to get out. So you need to look at the range of blends, ideally, to see if 95% is good enough. If you're happy with the results, you're looking at the 95%. Usually there's a sharp transition at some point when, let's say, the benefits of the new clean oil will dominate the problems and sort of wipe them out. So that go oil analysis and visibility. That's unfortunately it's time consuming and costly, but that's the only way, the only surefire way. Well, surefire. It's the only way of reducing the risk significantly. Then there are other very simple things like reading on the nameplate, making sure if someone is alive who remember what was actually in the system. Do you have analytical reports to confirm that this is mainly this or that, so you know where you're standing? Because there are lots of good guidelines in the 60422, and I'm sure there's the corresponding one with the IEEE guidelines on how to do it. So read the instructions. Everything fails. Read the instructions, and if you you try to fill up with an oil which is supposed to be compatible and miscible, that reduces the chances of nasty surprises for sure. Yeah, but you have to read up on it and try to figure out the documentation or get testing if there is no documentation. Right.
All right.
I would only add that the process itself to keep the process of retrofilling safe is those guidelines and recommendations are pretty similar for both oils. There's a new particular standard on retrofills being worked out as we speak for ICE in Europe that's going to add better cautions or more detailed explanations for esters in particular. So that's great. The process itself is not that different. What I would tell you is, in general, we always get more of the question of how much mineral oil is left. Does that matter or affect the mixing it up with natural esters? And the question is, after the proper cleaning process, heating things up and cleaning them up properly, there is always going to be about a 3 to 5% of mineral oil that's still in the system, because that's what it was usually operating with before. And that is perfectly normal, and it doesn't affect the function of the transformer later. But we have been very fortunate to have great partners in our retrofill channel in the US specifically, I'm referring to. And they've never reported a failure after a retrofill. So we're very happy to say that.
Okay. I got another one, and both of you, Nynas and Cargill, you make synthetic ester as well, correct?
We used to.
Used to. Well,
we might again.
Okay, you might have been. So here's the next question, and it is about synthetics. So I'm going to ask the question. I'm going to say, first of all, is the question correct? Why are larger amounts of ethane observed in DGA of synthetic ester oils? Well, the first thing I'm going to ask you, Claude, is that true? Are there large amounts of ethane in synthetic esters usually?
Well, for me, ethane is more with natural ester coming from one type of seed, and that's the omega-3 termination of the chains that will, when it break, will make the ethane. So I'm not sure about synthetic ester. I have to admit I don't have a lot of experience with synthetic ester. They are not that common. But for what I've seen, ethane is more with some brand of natural ester. And we did, by the way, we did study there at the request of a customer of 15 years, no, yeah, about 10 to 15 years ago, on gazing tendency of various type of liquids, including various ester. And we did publish that, and now they are part in some interpretation guide. But again, I apologize, I'm not really specialist of the synthetic ester. I have not come across them very often.
So let's assume that the question is correct. Javi?
Sure. I was just going to say, I don't remember top of my head. There's one of these components that does show up more in natural esters, and it's one of those fish climbing the tree thing where we have proven and proven and shown that the test is not, valid for evaluating a natural ester in particular. I don't know if this particular one is one of those components, but we can send that answer later to the participants in the chat too, of like what things of particular gases in analysis you will see a little higher of on natural esters, and it's normal to their function. It's not a problem.
Right.
Yeah, I would say an Nynas production is only IC60296 type fluid, so mineral oils, bio-based hydrocarbons, and re-refined oils. But we, of course, see our products in neck-to-neck field trials with synthetic esters as well. And yes, you always see more ethane. Whether or not if it's more pronounced with synthetic esters or natural, I don't know either. So, but yes, the data comes out differently. Yes, as Javi says, it is natural consequences of how these molecules behave under the HC. So, and of course that's why people turn to Claude and his friends for.
And they told him all nervous, and he says,
So it's most certainly not the same template for interpretation. Of course not. No.
Correct. And when I was talking about learning to interpret the result, that's one of the things I was referring to. It's the same gas, the same analysis, well, with some tweaking, but at the end of the day, the meaning of this gas as opposed to this one is different. We have to be careful when we do that.
The ratio interpretation is different, yeah.
Correct.
As Thomas said, find the guy that knows. Right. Find the person that knows.
Or the guy that knew the guy that will refer to it. More often than not.
Unfortunately, they're hard to find because they're with Sherritt moving to Boca Raton or something like that. Let's switch gears. A question. I love it when I'm not sure that the question is valid, because if it's a stupid, you can say,
People could be confused. That's good.
yeah. Well, here's one. What are the advantages? It's going to start with you on this one, Claude. So listen carefully. What are the advantages and disadvantages of using methanol and ethanol analysis versus furan analysis? And I don't understand those as equal to and or. Help me understand.
They are not equal. That's for sure. Furan has been the first to be proposed to the market to try to evaluate the condition of the paper. Methanol came later because furan have some limitations. Whoops. One of the limitations of the furan compound is they are generated reasonably late. They start to really appear when the paper is quite degraded. Methanol is kind of the reverse. It's more generated early in the process of degrading paper. So, and at the beginning, I was saying, well, it's more the use of the combination of the two that is useful. So you will see methanol early, and then you will see the furan appear later. Another complication that is, I won't say overlooked, but is not well known, is what we call the partition coefficient. How much of the methanol and the furan is in the paper in regard of what is in the oil. And you have a correspondence between the two. And that change with temperature is even worse than, almost as bad as water, let's put it this way. So another item there is the change in the load will change those compounds. And of course, if you change the oil or process the oil, you reset the clock and all that. So one is the complement of the other, so to speak. Now, ethanol is new, so is not well known and well used, but it's coming. Okay. Sorry.
I think also what Claude is saying is very true, and of course the general advice is to work with the trending and the trend analysis, because just a snapshot, we get these questions every day. My hydrogen is 500 ppm. Am I gonna die? And they say, no, we can. You can't just based on a single point. You can't say it. So work with the trends, observe the trends, and learn from how the units evolve. And it's very good, as you say, to have the early warning and maybe the mid warning and then the late warning and then the too late warning. But after a long time, you could draw some conclusions. But the trend analysis and keeping track of it, keeping track of the systems are the key for successful interpretation, in my experience.
Okay. Thomas, to your point, I had a professor once who said, give me one data point and I know nothing. Give me two data points and I begin to know something. Give me three data points and I can tell you the future.
Yes.
It was in that course that was talking about extrapolation and interpolation. What I want to do is I want to make sure that we leave some time, and we're running in that time. I'm going to ask you, Thomas, and you, Javi, to talk a little bit about, since your companies are sponsoring this power panel, I want you to talk about the company specifically. Where are you right now? What are you focusing on? Every year we do planning for the next year. What does your strategic plan look like for 2025? What's going on at Cargill? Because you're not just Cargill FR3 transformer fluids. You are now Cargill, responsible for Cargill Bioindustrials. And when I learned what that meant, I thought, oh my gosh, you've got more than one full-time job. You have 5 now.
No, it's the mission is beautiful of what we do in Cargill Bioindustrial. So I'm super happy about all of the businesses that are trying to grow from nature, renewable derived chemistries into the industrial world are having a great moment, which is a great thing for all of us. So overall, what we're doing, we are, like all this industry, trying to keep up the pace, trying to keep up the speed. On top of the supply-demand balance that in our dramatic, accelerated global increase of our capacity that we're doing, we know how important it is for people, specifically after COVID, to have that security of supply, the certainty that it's the same product everywhere, that it has the quality that it needs to have, no matter what plant it came from, because if one has to shut down, we will have the backup system to keep providing people and not cut this crucial energy industry. So we're working very much on that. Extensive expansion of our current plants, and we have more than 7 now and working on 6 other projects that are either expansions or new facilities to be able to keep up with that growth. I think my most important message that I want to leave, since we're almost done, is to say that this beautiful wave of growth of the energy, that the world just needs us to do better and more and cleaner and better energy. That means there's room for everyone to grow, but there's also a beautiful push in this traditional industry to look into new things and to be forced to innovate. You have 2 paths, right? You're barely catching up. You could say status quo, I'll stay with what I know. But the world is pushing you to look into these innovations like natural esters or high heat or whatever you call it, right? Because that's just my. But overall, that's happening. And also, we're very focused on teaching everyone that not all esters are the same. There's going to be a lot of new players coming in. So how do you learn how to evaluate them and trust them and still keep your knowledge and education up to date on all the confusion that might come to you? That's what we're working on the latest. Sustainability. Sorry. I'll take one more minute. Working on a transformer sustainability evaluation, except for just the fluid, moving from just the fluid carbon footprint to what is a full transformer carbon footprint, and how do we make that whole thing better?
We're going to do a whole one of these on sustainability. So remember that and come up. Yes, what's going on with you? And I know you do ester, but you're primarily a mineral oil, transformer mineral oil company, correct?
Yeah. We don't manufacture esters ourselves. It's a completely different value chain. So, Nynas is supporting the sustainable transition in across the industries for Beauchemin and the naphthenic specialty products that affects people's lives every day in electrification and road infrastructure. So it's very key products for society now and in the future. And our specialty is to refine non-fuel molecules into high-performance, long-lasting specialty products. We operate across international markets with a strong focus on Europe because we're based here in Europe. And we work with the customers to create the solutions and find new pathways forward to technical issues. For the transformer oil's future needs, of course, a long list of sort of wish lists, asks to keep lowering the carbon footprint of the production process. That's something that we're doing very actively with bio-based electricity and also green hydrogen very recently. Takes a big bite out of the carbon footprint. Scalable production to keep up with a very rapidly growing demand, and to maintain the supply of our products, which are readily recyclable. So we hope to see some growth of re-refined products also in our application. That's still very small. We want to keep it easy for the manufacturers and the owners or operators, keep the valuable and trusted fluid miscibility and material compatibility properties intact. New products with extended, let's say, cooling properties and lower viscosity to provide better ability to handle load swings, harmonics, and increased voltage fluctuations with a low inertia grids of renewable energy, which is a rapidly rising issue, of course, with the changes in production. And products that allow the same design principles and OEM practices to keep it simple and keep it scalable and keep it affordable, so that this magnificent growth can materialize. Right.
We'll come to a point where we don't all rise with this rising growth thing, but in the meantime, we are doing that. Claude, I'm going to let you finish with TJ. What's going on at TJH2B?
Well, still working on the Tecan, as you mentioned. We still have our worldwide group of laboratory. And as I point out, well, it's a learning process with those new material, those new situation, and we keep abreast of it. I mean, we keep studying, we keep learning, we keep interacting with our customer, trying to help the customer and the customer help us and giving us new case, new concern, new thing to look at. So I won't say it's life as usual, but it's certainly an interesting life.
One of the things I love about it is the guy that Thomas and Javi was talking about, go find the guy, that's actually you. So you are the guy that can help people make the determinations.
The guy that know where the guy is me.
Okay, that's perfect. This has been a delight. Thank you all so much. Claude, I'll see you in Atlanta at TechCon. Javi, you and I will see each other somewhere soon at some event. And Thomas,
we need to start a podcast.
Yes, for a podcast, exactly. Good to see you all. Thank you for joining us. This has been an APC Media production.
Thank you.